And so it's called Winter is Coming, a Kotlin web application without Spring. So my name is Maryna, and I'm a software engineer at OLX Group, which happens to be one of the sponsors of this conference. So you can check it out. It's pretty easy. I should say that the only thing linking this talk to Game of Thrones is its title, because I just couldn't resist it. But what we will actually talk about is how to build a web application without Spring, as in without Spring framework. And specifically, if you're working with the Java or Kotlin applications, you probably already know Spring, and especially Spring Boot, because it's kind of a de facto standard in developing microservices in Java and Kotlin. So why would you want to go without it, right? If it's so cool. Well, one thing about Spring Boot is that it's opinionated. They call it an opinionated framework. And what it means is it does a lot of work for you. But also what it means is you're basically driving a car and you do not know what's under the hood. So when something breaks, it's becoming really, really complicated. Only yesterday, I was battling a problem of OAuth in Spring Security, and it was just a complete hell. So a lot of developers don't like this feature, this opinionated feature of Spring Boot, and want to have more control over the app. So let's see if it's possible, right? And how much work it is. And suppose we want a simple REST API to back our awesome future application. And it should allow us to do the basic CRUD operations with the data. We want to have the API that would allow us to read, create, update, and delete our data objects. And in this slide, I listed the things that a standard web-based microservice usually contains. So web server running, logging, JSON serialization, REST API, CRUD, actions, persistence, stuff like this. So we will go and see how to implement them in a small Kotlin application. How do you begin? How do you know what the options are? Well, the simple way is to go to kotlin.link website. And there you have a lot of libraries and frameworks that are listed and separated by function. So if you look at the web components or web libraries frameworks there, you can see that the most popular by far is Ktor. And that's what we're going to use. So how do you start a Ktor application? How do you begin to create it? Well, the easiest way to create an app is to install a Ktor plugin for IntelliJ. And I happen to use IntelliJ for almost all the development. So for me, it was a simple, obvious choice. And when you install this plugin, you have the type of project simply called Ktor. And when you select it, you can see a lot of features listed on the right. So you can immediately include all those features in your application. But we will start simple. So I have selected call logging. I have selected Jackson to support JSON and a native web engine. So we will go to IDE and see the project. I have already pre-created it. And also one note, as we don't really have time to code everything from start to finish, I will be using Git branches. So Git branches that contain different stages of the application. So let's go to IDE. And yeah, I'm wondering if you can see my screen well enough. Let me quickly check. So nothing seems to be there in the chat. By the way, while I am presenting, I won't really see the chat. So I will read it after the talk is done, if that's okay with you. Okay, I see a lot of myself here. So let's go back to the IDE, and I will check out the first branch. And here you can see what's been generated. What's been generated with our Ktor type of project. So, come on, I have lost my presentation, sorry. Yep, here it is. I want it here. So, yep, here you can see we installed our call logging and we set the level to info. And we install our content negotiation feature, which basically describes how you process different kinds of content. So here is our JSON. We enable it for JSON output, and we enable the indent output, which is pretty print. So all these pretty DSL is part of Ktor. It's just kind of a helper function defined for you. And inside every feature, you can set up the feature, you can configure the feature. So this is the application module, also Ktor functionality, and this module is referenced in application config, which I will also show. And you see we already have routing, simple routing. We have two endpoints. We have our root endpoint, which is just simply /, and we have our JSON endpoint, which returns the map of hello to world. So let's check it out. Let's quickly run it. Okay, the application started, and I have created a couple of HTTP files to be able to show you the requests without going out from the IDE. So we will go to our root call HTTP file, which is simply the get call for our route. And you can see that it's our hello world. And we will check the JSON as well. And here is again our hello world, only in JSON form. But we want to return not the map, right? We want to be able to work with objects. So let's see if we got this also in build. And here's our application again. And here I have created a list of initial data, which we'll use. The person class is a data class, which is very simple, just the name and the birth year. And we have our initial data, and we will return it here instead of our map. So let's see. Restart the app. Run again and go back to our JSON call. And here we see our initial data. Okay. So this is our first initial application, and we already have a web server running. We already have logging here. You can see it in the console when the application starts, and we already have JSON serialization. What I haven't shown you is something that I wanted actually you to see. So the application conf file. The application conf file is specific for Ktor. You can see it's a bit different from what you usually see in Kotlin apps, because usually for Spring Boot applications, you have the properties files or you have the YAML files. But this thing is called HOCON. So this is human optimized JSON. It's easier to read than usual JSON. And it defines our module function, the enter function, and it defines some other deployment configurations. So this just means that the default port is 8080, but otherwise it gets it from the environment variables. And also one more thing, the build Gradle. So if we go to build Gradle, you can see that this is what was added when we generated our app, Ktor server netty. So we have logback for logging here. We have server core, we have Ktor Jackson, and we have the tests, the testing framework as well for Ktor. And also one thing I added here is the shadow jar task, which requires a separate plugin here. And this task will generate your fat jar, the jar with all the dependencies, and we'll put it in the build libs directory. So this shadow jar, it contains everything you need to just run the application as a Java jar and the app name. So let's go back to the presentation. And we have all this stuff, right? And now we need our CRUD. So now we want to be able to do something with our data. And yep, let's check the other branch. Let's check our REST branch. And let's go see what has been changed. So here is our application again. And you can see that we have still the same features. We have still the same, or more or less the same data, because I changed it to a map to be able to do something with it. But here our routing is extended. Now we have the get/person to get all the people, get person by ID here. We are using the post call to create or update a person, and we also have a delete here by ID as well. So what it does is just working with our data list. So it adds people to the list or removes people from the list or updates stuff like this. They're very simple. And these are just the HTTP methods that are being used. So there is usual methods like get, post, put, delete, and we're not using put here, but we will be in one of the other iterations. So let's quickly run the application again. application started, and what we want to be able to do is to add a person. First of all, let's go get all the people, check what we have. So it's our initial data. And this is a post request to add a person. We'll just add me. So it's 201 created response, which I return. And let's go back and try to get all again. So you see I'm the last one there in the map. Okay, we got this. Actually, I can also show you the delete, though it's pretty simple. So we delete me, we go back to get all, and we check that I'm not there. And if we try to get me by ID, you will see the 404 not found. So that's practically it, but let's see the code again. Yep, we still are working with our data here, which means that the data disappears once we stop the application. So our changes are not saved. That's why the next thing we want is persistence. And so persistence options are listed here. It is the same website I have shown you before. And I looked at the DB flow, which is the first one, but it seems to be only for SQLite. And the next one, which is pretty popular, is JetBrains Exposed. So Exposed is actually working with a lot of databases, and this is why I chose this. I want to just do MySQL database because it's popular and it's pretty easy. So let's go to our IDE again. And we take the persistence branch. And you will see what changed. So here you can see that our routing is pretty much the same. But what is different is that we now have a person repository. And we are calling a person repository to create, update, delete, read people. And we have our database connection here. So I will show you first of all the build Gradle. And here's our exposed dependency and my SQL connector. So MySQL connector, you need this separately. So for this simple app, I'm just using the Docker container, the local container for connection to the database, and it's defined in a Docker Compose. So the Docker Compose is here, and you see I got the newest MySQL, which is 8.0.20, but really it could have been anything because we're not doing anything complicated. And so here's the admin interface to the database, but we won't really use it. I want I was using it to just check the data in the tables when I was starting the app, because it's a pretty simple, nice, clean interface. You can try to use it for your pet projects. It's more convenient than just the usual console. So we have our Docker already started. Check again. Yep, it is. But the database is now empty. So if we go to our database, okay, there is a person in our database. One table in our database, because I already started the app, but no people yet. So, okay, let's start the app again. And now you see that the exposed, it ran the table creation here. So it's comparing the information schema to the objects you have defined in the app. And if there is no tables or columns that are defined in your app, it will create them. So let's go see what we defined actually. First of all, we want to see our person repository. So here's our person, and here is our person entity, person table, and person repository. So what comes from exposed library is person entity and person table. So you can see that the person entity is an int entity, which means that it's an entity which has an ID that's auto-generated, auto-incremented. But if you supply the ID, it will still take your value and not the auto-generated value. So it only auto-generates the value if you do not supply it on creation. And you can see that it has a name, and it's kind of a delegate property. So it says, see the type at the person table name, and the birth year, see the type in the person table birth year. And the birth year is defined here as an integer, and a varchar name here. So it's all exposed DSL. And the person repository is just an object, which is Kotlin way of making singletons. And it's wrapping our person entity and our person table. So our CRUD is defined here. And also we have a database class to define our connections. So this is what actually connects to the database. And here you see that I have actually two options, because I wanted to have a different database for testing, using test containers to start the MySQL test container while the test is running. It means that it starts the container, runs the tests, and then it kills the container. So you always have a clean database for tests. And here you have the normal connection, which is connecting to JDBC. So exposed is just an implementation for a wrapper around JDBC. And what it means is that it's not reactive, it's synchronous, it's blocking. But for our case, that's enough. That's simple, working, and that's what we need. And here is what creates our missing tables and columns. Here's what's checking the schema for our person table. And that's basically it. So let's go see what we're still missing. And this is the big one, the dependency injection. So the candidates here are coin and codeine, and they're both popular. And how do we even choose? Well, first of all, we can see how well they are supported. You can see that they're updated pretty recently, both of them. So there is a lot of work still going on. You can look at the GitHub starts, you can look at the features, you can look at the number of open issues, but it's kind of two-sided because a lot of open issues means that people are working on the projects, but also it means that there's probably some problems. But in the end, it's kind of a matter of taste. So I looked at both and I chose Coin because it just looked easier. It was more readable, which is also pretty important. So if we go to the IDE and get our branch where there is this dependency injection stuff, you can see that our code hasn't changed much, but we have here a person service instead of the person repository. And what is the person service? So this is where it starts getting interesting. Person service is a person service type, which is here. It's just wrapping our person repository. By inject. By inject, meaning that it gets the instance of our person service from application context. So what does it mean? It means that we define the context in the module here. This is already a coin module, not the Ktor module. And you're saying here, I want a single instance of a person service, and I want a single instance of a person repository. But what is this get, right? So if you go to person service, you see that there is a one constructor parameter, the repository. So it needs the repository on creation. And this get simply tells to coin, get the person repository instance from the context. And here is where create happens for the context. Here's where we create our singleton for a repository. So I will not show you how it's running because it's pretty much the same. We only wrapped a person repository into the person service. And what we also have here is I will show you the dependencies we added, and it's really not much. So there is a specific dependency for a coin with Ktor, and there's a couple of dependencies for unit tests. So this was our dependency injection. And now we come to authentication. Why I marked it blue instead of orange? Well, actually, because we will not talk about it. We will not go there. Why? Because it's a pretty big topic, but also because this is a functionality that's kind of inbuilt in Ktor as well. So in Ktor, you have all these options for authentication. You have basic HTTP authentication, which just includes username and password being passed to the server in the authorization header, and it's base 64 encoded, but it might as well be plain text because base 64 is reversible. So you have a digest authentication, which is encoded, hashing the password with MD5 hash. You have JWT auth, which is very widely used and very popular. But we won't really have time to code all this. So authentication is something that I skipped here. So what I didn't skip is observability and metrics. And why exactly am I stopping here and not on authentication? Well, because I think that metrics are often underestimated. So metrics are often an afterthought of having everything in place. So you code everything and then you remember, okay, we don't have any metrics. But while you don't have metrics, your application is basically a black box. You do not have visibility. You do not know what is happening. So in Ktor, again, you have a couple of built-in options for metrics. And first is Drop Wizard, and second is Micrometer. So both libraries are widely used. Drop Wizard is a bit older, and it was used by default in Spring Boot 1, and Micrometer is used by default in Spring Boot 2. It's a bit newer. We will go with it because it's newer, but it's pretty much the same stuff. So back to the IDE. And here's our metrics. And you can see that we are just installing the micrometer metrics as a feature. And we have our registry, which is also injected in the context. So we create it here. And yep, why Prometheus? Well, I chose Prometheus because it's something we use in production. So we use it for all our apps. And Prometheus is an implementation which is not push-based, but pull-based, which means that Prometheus service polls our application for metrics, and the application should return the metrics to this service in a specific form. So it's just a web page in a specific format. And here I added the Prometheus endpoint, which just scrapes the registry, which means get all the current metrics and expose the current values to this page. And we are just spitting it into the response. So let's see how it looks just out of the box. Okay, we run the application and we want to go and see some metrics. So let's query our Prometheus endpoint. And you see that we have a lot of stuff already there, like a lot of default metrics. So you see the JVM memory metrics, you see the Ktor specific metrics, you see the garbage collection metrics, memory used, buffer, thread state, a lot of stuff. But what I want to show is actually we want to know how our application is performing, right? We want to know how quick are our methods, our endpoints, our queries. And this is why I have another branch to show you. So you can see that here I removed all the meter binders. So I replaced the default meter binders, which are all those GVM metrics, with just uptime metrics. And also we need our metrics for the REST calls. But to have those, we need to actually perform some REST calls first. So we run the application. And we use this to get some load into the app. So we're sending the queries. And let's see our Prometheus endpoint again. See, these are metrics for the server requests. It's in percentiles, so it means that half of our requests is under 4 milliseconds. 95% of our requests is under 4 milliseconds. So, okay. Yep. And what if we throw a bit more load here? Let's make it 1,000. And you see that now it's much slower. So let's see again. And if you look at the Ktor server requests active, you see that it only has 2 active requests at a time. Okay, it's finished. But what if we increase concurrency? What if we do the same 1,000 requests, but we want a concurrency of 100? Should be very quick, right? But you see, it's pretty much close to what we had before. So let's see our active requests again. And there is 8. And I will explain why it happens. So what Ktor does, it has these threads pool for performing application tasks. And by default, you have as many worker threads as you have cores. And my machine only has 8 cores, so it doesn't really make sense. We can set a concurrency of 1,000, and it will still not be able to really run 1,000 requests at a time because I only have 8 cores. And yep, why is it a little bit slow? It's because there is one other thing we do not have, but which I really did not have time or scope enough to implement. It's caching. So in a production application, of course you would have it. But there's a lot of things that I had to left out for this app because it's not a production rate app. It's just an example. So my takeaway, would you go without Spring? I have listed pros here and cons, which are there for me. So without Spring Boot, you might have fuller control over the app. You might have a smaller size of the app. You might have faster start time, though on such a small application, it's not really obvious. But the main thing here is just expanding your horizon, seeing what else is there, trying new things. The cons would be steeper learning curve, less documentation, less path, less clear, less trodden. So it's not as feature rich, probably because it just had less time there. It might be a longer development cycle, and it might be, so the main point here is that it might be difficult to sell it to the client because of the uncertain support prospects, because you don't know if this framework will still exist in half a year, right? But still, if I was working on a pet project or a side project, I want to learn as many new things as possible. I want to explore. And I think it's very valuable. So, do you have any questions? I see that I am exactly 40 minutes here, so I'm not sure. I will check. Could we have a link to your Git? Yes, it's in my last slide. Okay, I will stop sharing. Yep, the link to my Git is in my last slide here. And I will also post it to the chat. So thanks everyone. Have a good conference. See you.